Our next guest is the Senior Director for Climate Strategy and Technology at ExxonMobil. He plays a key role there in guiding that company's approach to reduce greenhouse gas emissions and address climate change. Today, he's going to share his strategic insights on how innovation and energy are the vision for a sustainable future. Please welcome Vijay Swarup. Have fun. Enjoy.
Wow. All right, we're almost near the end, and it's good to have an energy talk near the end because we're going to try to light you up with a little bit of energy. And what I want to do, there's been some amazing storytelling so far today. And so I'm going to tell you a story. We're going to talk about the story of energy. Because quite frankly, there's only one thing that ties everything that you've heard about today together, and that is energy. Imagine this room without energy. And none of you thought about it. When you woke up this morning and you turned your lights on, you didn't hope. You didn't say, I wonder if the lights are going to come on. It's taken for granted. And yet, just about 150 years ago or so, let me show you what energy was like. So let's start the story on energy. And we're going to go through this pretty quickly, but 150 years ago, life was just fine. This was modern medicine. You could do what you wanted to do. Burn the midnight candle, you could pull an all-nighter. You could absolutely do what you wanted to do. How much better can life get? You had ink, you had pens, cameras. I haven't quite figured out how you play music on that thing, but you could take a picture. You could remember what it was like. You had modern washing and drying. This wasn't that long ago. Let's see what else they did. You could cook. You had heat. You could cook inside. You could cook outside. There's biomass. There's coal. There's all sorts of things to cook. We had systems and measurements. We've heard a lot today about wearables and knowing what your pulse oxygen is and everything. We could do systems and measurements back then. We had the ability to do that. We had modern communication. We had telegrams. We had the printer. We were able to do things. And of course, we had modern transportation. We could move from point A to point B. That horse has all-weather hooves, okay? So we could do those things. We had an industry. We had an industrial sector. We had pulleys. We were able to take biomass, get power, turn it into things. This was as good as we were going to get. The textile industry was taking off. It was not exactly dry fit, but it fit. And you could do what you wanted to do. And we had supercomputers. I don't know what these guys are talking about with all this stuff they're doing. This thing right here, it still amazes me that they could do all that modern math with an abacus. So it is all about innovation and energy. Now let's just fast forward a little bit because a couple of things happened that really changed the world. One was synthetic chemistry, and of course, there was light. And with light, everything changed. And now let's just fast forward about 100 or so years, and let's talk about energy today, because it's not quite what it was like. But the objective is the same. The objective is to move around. The objective is to have better health. The objective is to have a better quality of life, all underpinned by energy. That's allowed populations to grow. That's allowed us to live in different locations. There was Florida without air conditioning. Wasn't nearly as much fun, but you had it, okay? And pickleball. Think about all the energy that goes into pickleball. I understand that's pretty popular around here. Okay, let's talk about this though, because today, just think about all the stuff you heard about today. And it's all about energy and innovation. I would argue that there is no sector out there that is more innovative than energy. And we're going to peel this onion a little bit further as we continue on our story. But just look at the things that we have today that, quite frankly, when I started in this industry in 1987, I would not have even imagined it. I mean, it is unimaginable what we're doing. We're at an imagination conference, and I can't imagine what we were doing. So we have electric vehicles. We have artificial intelligence that we've heard a lot about. We have a phone that the last thing you use it for is a phone. When's the last time you made a call on your phone? My kids don't pick up if I call them. If I text them and say, I'm going to call you, they will answer. But if I call them directly, no chance. No chance. You got to text first. I don't understand. But we're able to do that, and we're able to do that and take it for granted because of all the innovations, the thousands and thousands of patents, the innovations, a lot of it in America, a lot of American technology in this. And today we have 8 billion people on this planet. Amazing. But let's talk about that 8 billion people. And let's talk about what is still happening today. So what's this energy challenge? Look at these pictures. Now, did I just AI the pictures from the first set with color? No. This is today. This is what 1 billion people still face. 1 billion people do not have access to energy. 3 billion people don't have access to modern living conditions. That's 3 out of 8. That's 1 out of 8. That's a lot. And yet I just showed you all the technology we have. And this is still happening. Seems like we should do something about that. And of course, we can now because we have ample energy. The technologies that have been developed over the last 20, 30 years, fracking in the US, who'd have ever thought the US would export the amount of energy we export? Renewables, lithium-ion batteries, the grid connectivity. We know how to do this. But the problem with this slide is it says the global energy challenge. Singular. It's not singular. It's a global energy dual challenge. Because while we have all that technology, one of the running themes that we've heard about today is we have to reduce emissions. So while we have energy, we have to remember that emissions are going up. And so we have a global energy dual challenge. That's the next chapter of energy. How do we take on this dual challenge? How do we continue to provide the energy that all of you take for granted, that 1 billion people think is magic? And how do we do the things that the previous 2 or 3 speakers just talked about, which is we've got to get our hands around emissions. We have to bend the curve, to use the Anthony Fauci term. We have to get the emissions down. At the core, this is a technology challenge. Yes, it's going to have to integrate with policy. Yes, it's going to have to integrate with infrastructure. But the technology is what I want to talk about, because that's where we got to think about how we do it, and we've got to get on with doing it. Now, to really understand energy, the other challenge is, the third dimension of this is scale. So let me talk a little bit about how we do this. So scale. This is a picture of our Baton Rouge complex. When I started back in the dark ages, 1987, 300,000 barrels a day, something like that, was a world scale facility. That's now an expansion. The scale of this industry. So I'm going to talk about scale in terms of magnitude. I'm also going to talk about the scale of energy in a different way. And that's the integration across technology. So if you want to be a pharmacist, what do you study? Pharmacy. If you want to be a biologist, what do you study? You study biology. If you want to be an energy scientist, what do you study? There's no degree in energy. Energy is the ultimate interdisciplinary industry. It requires every discipline of engineering and every discipline of science working together. Chemical engineering, mechanical engineering, nuclear engineering, civil engineering, blah, blah, math, physics, chemistry, biology. Throw in economics, throw in policy, throw in social science with the equity and the just transition, and all of that has to come together. So, magnitude of scale, complexity of scale, integration of technologies, geographical differences. Other than that, no problem. Now, scale. How many of you know what the city energy system is? 600 quadrillion BTUs. How many of you know what a quadrillion BTU is? No? How about an exajoule? No? No exajoules either? How about a terawatt? Petawatt? Anything? No? 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 It's a lot. Yeah, there's probably some engineers out there that know this, but stay with me for a minute, okay? Because I'm going to try to put this in context. So let's talk about something you might know. Let's talk about energy. 45 round trips to the sun on a 747. That's how much energy we use in a year. Still not impressed? Okay. How about 40,000 trillion AA batteries? No? And I can never find one that works, okay? We would need 4 quadrillion. No, still not there? How about 240 trillion Big Macs a day? A day. I know there's some students out there, that's just lunch, I know, but 246 trillion, the size of this is amazing. It's always just, I'm fascinated by scale. I'm fascinated by scale, and I'm fascinated by the inability for us to express scale. This is going to take collaboration and innovation at scale to reach the dimensions of scale that we need to get to. That's our challenge. People like to boil this down to a simple thing. This is a very complicated problem, which needs serious discussion and serious technology development and serious collaboration. So we're going to talk a little bit about, well, what exactly does that collaboration look like? Because we know how to do this. I just showed you about all the innovations we've made. They've been made through tremendous collaborations. Universities working with industry, working with national labs, working with across governments, across countries. That's what we need to do. So we need to collaborate and innovate. And if we do that, let's talk about some of the technologies that are on the horizon. Now, we've talked a lot about AI, but that thing in the upper left, that's actually what's got me pretty excited. And that's quantum computing. I know the previous speaker mentioned quantum very quickly. But quantum computing is going to allow us to understand energy and nature at levels we never have. So we'll be able to model energy systems and move products around and design materials like we never have. You hear a lot about hydrogen. Why do people talk about hydrogen all the time? Because when you burn hydrogen, you get water. You don't create the CO2. The question is, how do you make the hydrogen? So you have to combine technologies to make the hydrogen. What else can we do? We can come up with carbon capture, the picture in the middle. So the CO2 is made, but if you capture it, and then you have 3 choices of what to do. You can either convert it into something you want, you can use it as is, or you can bury it. Okay? But the first step is you have to capture it, and again, you have to capture it at scales that just haven't been demonstrated yet. Plastics. Plastics allow food to stay fresh. It is why we have blueberries 12 months a year, because you can move food around. But we need better plastics to continue to have food preservation, have the quality, lighter weights for cars, more durable. Some of the pictures here are these high strength polymers that can back out steel, back out concrete, 2 very, very high energy intensive emissions emitting sectors. But if you can get a polymer to do it, a plastic to do it, there's no emissions associated with that. Now there's emissions associated with making it, but not with using it. So again, combine a couple of pictures here. Take carbon capture on the back of a plant, make the product you want. You can start thinking about how this goes. Now, truth be told, those are things we're working on, okay? There's a lot of other technologies out there. Let's just start listing some of them. In fact, there's a National Petroleum Council report that was written that I encourage you to read that talks about the technologies that are on the horizon. It talks about geothermal. It talks about renewables, solar, wind, tidal, ocean currents, biofuels, biology, all of these things. And again, what's the common theme? They integrate across disciplines to solve a common problem. Because here's the one thing we know, we're not going to go backwards on energy. We only go forward. The evolution of energy is always improving. That's what's fascinated me for 30 plus years, and it's going to fascinate me for a long, long time still. So let's talk about this now. And look, Randy does this. This is an amazing conference. And one of the things I like about this conference is the range of people. We have kids from 6th grade, 7th grade, 8th grade, and then we have energy titans here. So we all know that when you work together, innovation happens. Imagine McCartney and Lennon not together, okay? Innovation happens. Look at patents. Patents always have co-authors. Innovation works together. So if we can inspire the kids today to think about it, to raise their hand, to step up and say, I think I have an idea. Let's work it. Let's get them in the STEM programs, because everything's going to be needed. As I said, we need all of these disciplines to come together. And then you get these guys who get, and the guy in the middle, he wins, right? His light went off first. But let's fast forward a little bit, because we're just coming off of one of the most consequential collaboration events ever. And this was COP28 in Dubai. I had the honor of going there and spending the better part of a week there, where you had industry and government, startups, everyone coming together. This is a problem that needs inclusion. It needs people working together. It needs collaborations at scales that we just haven't seen. That's what we're here for. That's why we do these conferences, to drive the discussion forward, to understand the problem, to put the capabilities behind the problem. And then, as it says there, this is an innovation challenge. This is an imagination challenge. This is an innovation challenge. And if there's one word that you take away from this talk, it's got to be scale. We have got to do this at scale. And so we've got to understand how we go from lab to scale. And we're beginning to see things happening. You see the US IRA, which is enabling deployments of technologies. Projects are moving forward. You see people starting to think about this. You've seen some talks today, challenging paradigms on how Manu's talk is a perfect example of that. Those are all low energy consumption ideas, but they serve the purpose. So there's nothing we can't do, if we put our minds together and we work together. And that's the core of the speech. We have got to innovate, innovate, innovate. Because if we do, it all comes together, okay? Yesterday's abacus is today's generative AI, is tomorrow's quantum computing. The horse became the car, is going to become the electric car. We're going to go to the grid. We're going to do all these types of things. Because if we imagine, we'll be able to swipe right, and we'll be able to walk ourselves into the future. Imagine that. Thank you very much.